Sorry for the technical issue. So we'll wait for 2 minutes to other people to join. Sorry for that. So we'll start. We were there on 39 question. Okay. So 39 question மட்டும் கொஞ்சம் elaborate 5 minutes discuss பண்ணலாம் because we got hybridization, geometry எல்லாமே இருக்குது. ஸோ அதுக்கு ஒரு ஷார்ட்கட் மெத்தட்னா hybridization of coordination compounds. See, நம்ம NCERT it is only for coordination number 4 and coordination number 6. Okay, so we'll first start off with coordination number 4. So for coordination number 4, we got two hybridization, that is sp3 or dsp2. So sp3 it is tetrahedral, and for dsp2 it is square planar. So these are the two hybridization we have for coordination number 4. Okay, ஸோ இப்போ நமக்கு எந்த கோஆர்டினேஷன் நம்பர் வந்துச்சுன்னா எந்த காம்பவுண்டுக்கு எந்த கோஆர்டினேஷன் நம்பர், எந்த காம்பவுண்டுக்கு என்ன ஹைபிரிடைசேஷன் ஈஸியாக கண்டுபிடிக்க. பிகாஸ் வி ஹேவ் லாட் ஆஃப் எக்ஸப்ஷன்ஸ், வி ஹேவ் லாட் ஆஃப் இந்த மாதிரி லைக் தி கன்வென்ஷனல் மெத்தட் ஆஃப் டூயிங் இஸ் இந்த மாதிரி பாக்ஸ் மாதிரி போட்டு வில் எக்ஸ்டேட் தி எலக்ட்ரான் அந்த மாதிரி நிறைய பண்ணோம். பட் ஈஸியாக எப்படி பண்ணலாம்? வி ஹாவ் 3 set of rules. Before that, we want to know what is the spectrochemical series. You want to know the spectrochemical series. So we got halogens. So what is spectrochemical series? Order mattu we want. So from iodine I get bromine. Sorry. Iodine, bromine, chlorine, fluorine. Okay. Then we get hydroxide. We get oxalate. Then you get water. Then we get amine. Then ethylene diamine. We got nitro. We got CN. Next we'll get carbon monoxide. This is a spectrochemical series. The easy way to memories. No, it's just a mnemonic. This is, halogens. How amines become ethylene diamine? Ask NCC. See, H is for hydroxide, O for oxalate, W for water, A for amine, En for ethylene diamine, N for nitro, C for cyanide, and other C for carbonyl compound. How amine becomes ethylene diamine? Ask NCC. This is just a mnemonic to memorize the spectrochemical series. Okay, so we'll move on to how to find the hybridization. So for coordination number 4, so for coordination number 4, we have set of rules. The first rule, metal. So if you want, you can copy down also. I'll write the rules. So metal of 12th group straight away with any ligand, straight away with any ligand, you can tell it is sp3 hybridized. That is zinc, cadmium, mercury. It is, that is the metal of 12th group. That's the metal of 12th group. Okay, metal of 12th group. The second rule is in excited state. Suppose take it for example Mn positive, Mn positive configuration from D0, D1, D2, D3, and D4. 1, 2, 3, 4, and 5. D0, D1, D2, D3, D4, D2, D3, and D4 with any ligand. Say with any ligand, say it is DsP2. And third, ligand of group A. Suppose ligand of group A, that is up to water, and ligand, suppose taking of group B, that is up to, that is from oxalate. No, water from amine, from water and from amine. That is group B. The remaining, say up to water, it is sp3 hybridized, and this is dsp2 hybridized. But we got three exceptions here. Tetracarbonyl nickel, tetraamino nickel, tetracarbonyl nickel, tetraamino nickel, 2 positive, CuCN 4 times, CuCN 4 times, 2 negative, CuCN 4 times, 2 negative. See, in this, what we have to know, if it is tetracarbonyl nickel, you have to get dsp2 hybridization, but we get sp3 hybridized. This is ammonia. Up to ammonia, we have to get dsp2, but we'll get sp3 hybridization. For cyanide also, we'll get sp3 hybridization. This is the rules to easily to find the hybridization in coordination compounds. So I'll give 3-4 examples. So that we can solve. So if you want, you can take down this. Find hybridization for the following. Find hybridization for the following. Find the hybridization for the following. Okay. We have rules here. Metal of 12th group, zinc, cadmium, mercury, straight away say it is sp3. And for D0, D1, D2, D3, D4 configuration with any ligand, it is dsp2. And for group A ligands up to water, we get sp3. And for up to from ammonia, we get dsp2. And this is the exceptional case. Okay. So we'll look on to the first question. Cadmium, En2, 2 positive. Straight away, it is cadmium, zinc, cadmium, mercury with any ligand. Straight away, it is say it is sp3 hybridized. Straight away, it is say sp3 hybridized. For next, zinc with nitrogen compound, that is nitro compound. Again, we know with zinc any compound, straight away say it is sp3. For copper in presence of ammonia, tetra ammonium copper, the rule is the last rule. With ammonia, any ligand, it is dsp2, and there is no exception also. So straight away you can tell it is dsp2 configuration. It is dsp2 configuration. This is for only tetrahedral geometry. It is for only tetrahedral geometry. So again for octahedral, octahedral complexes, we also have some set of rules of coordination number 6. Geometry is octahedral, sp3 d2, or we get d2 sp3 configuration. So we have sp3 and d2 sp3 configuration. So we get sp3 and d2 sp3 configuration. So we have again 3 rules here. So if it is sp3 hybridized, so with metals with zinc, cadmium, mercury, along with nickel, palladium, and platinum, so with any ligand, straight away say with any ligand, straight away with any ligand, it is sp3d2. Straight away you can say it is sp3d2. Next, metal with n plus configuration from d0, d1, d2, d3, d0, d1, d2, and d3. Straight away say it is d2 sp3 configuration. It is d2 sp3 configuration. It is d2 sp3 configuration. Again, for ligand of group A and ligand of group B. So here, what is group A? The group A is up to oxalate. This is group A, and from En to CO, it is group B. So this is group A, and this is group B. This is up to oxalate. So, so group A is up to oxalate. Group A is up to oxalate, and group B is from 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 diamine, that is from En. So first group A with oxalate and group B is from En. For oxalate it is sp3d2 till oxalate, and from En we get d2 sp3. Okay. Okay. But I have missed one thing. What happens to water and ammonia? How it is for water and ammonia? Suppose water and ammonia, if it is M2 positive, straight away say it is sp3d2, and for M3 positive, it is d2 sp3. Once you solve questions, you'll get better idea for this. This is a very easy method to find the hybridization of the complexes. So we got some exceptions here. So if it is metal 2 positive with water or ammonia, straight away say it is sp3d2, and for M3 positive it is d2 sp3. But the exceptions are the exceptions are Fe H2O 6 times 3 positive. So water 3 positive, it should be d2 sp3, but the hybridization is sp3 d2. So exception, it is sp3 d2. It's sp3 d2. Next, here there's again one exception, cobalt with oxalate. Actually, with oxalate, we have to get sp3d2, but this is d2 sp3. d2 sp3. This is about complexes of octahedral complexes. So we'll move on to the question and we'll discuss. Okay, you can take a screenshot or snap of that and we'll apply here. The question is geometry hybridization and magnetic moment for the following. So M and B are 4 times, right? And Fe F6 4 times, 6 times whole 4 negative, and nickel tetracyanonickelate 2 ion. Okay. So seeing in the options, this should not be the answer because it is octahedral. No. So 1, 2, and 4 should be the answer. So again, FeF6 should be octahedral. So this should not be the answer. And this should not be the answer. The option is actually 2, but we'll discuss uh, how we'll get the 2. Okay. So M and B are 2. I told till have to look at the yeah, this is for this. See, up to water, it is sp3 hybridized. See, first we have to look whether it is in 12th group element. No, it is not 12th group because it is M and B are 4 times, right? So whether it is coming in D0, D1, D2, D3, D4, with any ligand, it should be DsP2. So manganese Mn2, that is D5. So we'll check my question. 1 minute. Okay. Mn Br4 2 minus. Mn Br4 2 minus. Mn Br4 2 minus. This is Mn plus 2 minus 4 is okay. Okay. So whether it is coming in next set of ligands, no, because Mn2 positive is D5 configuration, right? But here it is up to D4 configuration. So in the rule it is not there. So it is coming into up to water. Up to water is sp2 hybridized. So this answer for this is sp3 hybridized. Okay, this is sp3 hybridized. So tetrahedral geometry with sp3 hybridized. Tetrahedral geometry with sp3 hybridized. Correct. Next, Fe F6 whole power 4 minus. So Fe F6 whole power 4 minus. So this is octahedral complex. So octahedral complex Fe F6 4 minus. Okay. So this is nickel palladium. This is not there, and D2 this is also not there. This is group A. So straight away you can tell it is sp3D2. There is no exception. This is one exception, and that is one exception. So you can straight away say it is sp3D2. It is straight away say it is sp3D2 with octahedral geometry. Next you have nickel tetracyanonickelate NiCN 4 times, right? Okay. NiCN 4 times 2 negative. So it is not going to come in first option, first rule. It is not going to come in second rule. It is going to come only at third rule. That is from ammonia will get DsP2 configuration. There is no exception. Okay. So this is DsP2 configuration. So we'll check. This DsP2 configuration. So the right option is Option 2, tetrahedral octahedral square planar with sp3d2 sp3 and dsp2 configuration. Hope it is clear. So after completion of the live, you just pause the video and you can take notes of the octahedral and tetrahedral complexes. That is how to find the hybridization, and you can solve questions. Okay, so this is about 39th question. We'll move on to 40th question. Boiling point of this is 40th question. Boiling point of alkyl halides. Boiling point of alkyl halides is in the order Ri greater than Rbr greater than RCl greater than Rf. Okay. So the reason is boiling point of alkyl halides increases with increase in the molecular weight. Okay. So we know that boiling point, that is increase in the molecular weight, will get increase in the boiling point. As mass increases, boiling point also gets increases. Okay. This point is correct. So we know that Ri have greater mass than Rbr, than RCl, than Rf. Okay. So the first point is correct, and the reason statement is also correct, and it's also the correct explanation for the assertion. So 40th question, first number 1 is the right answer. So moving on to next question. Moving on to 41 question. Moving on to 41. Glucose on reacting with HCN and getting hydrolyzed, again treated with HI in presence of heat. So 41st question. Glucose on treated with HCN, hydrolyzing, then on heat. Okay. So glucose on treating with HCN, on hydrolysis, then on heat and HI. This is the question. Okay. So the structure of glucose is CHO, CHOH, CHOOH, and CH2OH. This is 1, 6, so it should be 4. CHOH 4 times. This is the structure of glucose. This is structure of glucose. On reacting with HCN, this C double bond O is converted to CN. That is CN CHOH 4 times, and you get CH2OH. On hydrolyzing, this CN is converted to COOH, and this is COOH 4 times, and this is CH2OH. Next, on treating with hydrogen iodide in presence of heat, the all OH group is getting converted to hydrogen. The all OH group is getting converted to hydrogen. So what will be the answer? This OH is converted to hydrogen, that is CH3. Again, all 4 OH is converted, that is all 4 OH is converted to H group, that is CH2, CH2, CH2 and CH2 with COH. 1, 2, 3, 4, 5 and 6. This is propanoic acid. Propanoic acid. It's propanoic acid. This is propanoic acid. So we'll see the options. We'll see the options. Sorry, what is? Okay, we missed one carbon actually. Okay, here there is. We missed one carbon. Meth, eth, prop, but, pent, hex, heptarate. This is not prop. Sorry. Actually, what happens here is, here we got C double bond O and hydrogen, right? So here we get CCN and you get OH, right? The CN go binds here, H will go here. So it is OH 1, 2, 3, and you get hydrogen here. So here we got other CH and OH, that CH and OH. Now this OH is converted. So here again you get CH2. So this is heptanoic acid. This is okay. Now it is 1, 2, 3, 4, 5, 6, and that is heptanoic acid. The right option for this question is heptanoic acid, option 1. For 41, the right answer is option 1. So moving on to the next question, 42nd question. From different sets of data of T half at different initial concentrations, say A, for a given reaction, the product T half multiplied by A is found to be constant. The order of the reaction is. So T half multiplied by A is a constant. So what is the order of the reaction? You have to know the T half for the 0 order, first order and second order. Okay. So for 0 order reaction, what is T half? For 0 order reaction, the general formula for 0 order reaction, general formula for T half is A upon, sorry, it is A upon 2K. Okay. In our question, it is given T half multiplied by A. So that is equal to A square upon 2K. That is not a constant because the say for A is, see, from different sets of data, T half for different initial concentration, say A. So there is a different initial concentration. So A is not a constant. So it is not the 0 order reaction. Say for example, first order reaction. For first order reaction, T half is a constant. T half is a constant, but T half multiplied by A is not a constant. Why? Because A is different. A is different. So it is not first order reaction. Say for it is a second order reaction, T half is equal to the general formula for second order. T half is equal to A by K. Sorry, T half is equal to T half is equal to T half is equal to 1 by A into K, and T half multiplied by A is equal to 1 by K. That is a constant. So it is a second order reaction. It is a second order reaction. Second order reaction because it is the general formula 1 by A into K for T half. Next, 1 by K is a constant. 1 by K is a constant. So now right answer for the 42nd question is option 1. So we'll move on to next question. 43rd question. Move on to 43rd question. It is the question from say electrochemistry. This is from kinetics, this is from electrochemistry. So every chapter will get at least a minimum of one question, and organic will have more weightage. That is, we'll get combination of questions, like from 2 chapters we'll get a question. Combination of questions we'll get. If you have any doubts, you can put in the comment section. Okay, yesterday's evening shift was tough. Okay, but compared to the paper section, January section is a bit more easy. So எப்போதுமே January section you try to write. Okay. Hi. So we'll move on to 43rd question. A 0.05 molar KOH solution offer a resistance of 31.6 ohm in a conductivity cell of cell constant 0.367 centimeter inverse at 298 Kelvin. What is the equivalent conductance of KOH solution? What is the equivalent conductance of KOH solution? You have to find what is the equivalent conductance of KOH solution given the concentration of KOH solution, resistance, and cell constant is also given. Cell constant is also given. So kappa is given by 1 by R into L by A. All right. Kappa is kappa is 1 by R into L upon A. What is the equivalent conductance? Equivalent conductance is given by lambda equivalence is given by equivalent conductance is given by kappa into 1000 divided by normality or molarity. Usually we take normality. So solving this, 1 by resistance, that is 1 by 31.6 multiplied by cell constant is 0.367. Substituting this kappa here, that is 0.367 multiplied by 1000 divided by normality is given as 0.005 molar. This KOH solution, so normality is also 0.05. 0.05. On solving this, this is 100. On solving this, we'll get fourth option, 232.28. 232.28. Okay. So we are running out of time. So calculation part, please you do. But this is the answer. Next we got 45th question. A simple question, 45th question. So what is 45th question? So 45th question, 100 ml solution of dibasic acid is prepared by dissolving 2.94 gram of it in water. 25 ml of the solution was neutralized by 15 ml of one normal NaOH solution, molecular weight of the acid. So we are having a dibasic acid which is prepared by dissolving some compound with 2.94 gram of it in water. So with that solution, this is the solution we have prepared with 2.94 gram in 100 ml. 100 ml solution of dibasic acid. This is a dibasic acid. Again, another solution we are having one normal NaOH. One normal NaOH. Okay, one normal NaOH. 25 ml of this solution was neutralized by 15 ml. So 25 ml is neutralized by 15 ml. So 15 ml is equivalent to 25 ml. That is the concept. So N1 V1 that should be equal to N2 V2. Suppose N1 we are taking it as NaOH. So normality of NaOH is 1. Volume taken is 15 ml. And N2 we have to find volume taken is 25 ml. For N2 it is, say for example, normality is, say molarity into, or we'll do separately. So normality is number of moles, that is mass divided by equivalent mass into volume. Equivalent mass is mass upon molecular mass by valence factor multiplied by volume. So this is molarity and valence factor will come. So molarity into, you got valence factor. So molarity into valence factor. So this is molarity into valence factor multiplied by 25. How to find molarity? It is number of moles. Number of moles is given mass divided by the molecular mass that we don't know. Multiplied by 1000 divided by, that is volume. So molarity it is volume. This is molecular mass. So volume is 100 ml. So in liters it should be 100 upon 1000. It's a dibasic acid, so multiplied by 2. And we also have 25 here. And here it is 15. On solving this, molecular mass, so it is 10. So 2.94 multiplied by 10 into 50 divided by 15. Okay. So it is 100. 100 into 2 is 200. Almost 3, that is 300. 300 divided by 3 approximately equal to more or less 100. It should be, see, it's taken as 3. This is 2 into 50 is 100. 100 into 3 is 300. 300 divided by 3 is not 300, not 100. It should be less than 100 because it's 2.94. So less than 100, only one option, 98. 98 is the answer. That is option 2 is the right answer. For 45th, that is option 2 is the right answer. Hope it is clear. Hope this question is clear. So we'll move on to numerical section. We'll solve, it's running last 5 minutes. So numerical question. So we'll do 47th question. What is 47th question? Hydrogen electrode is dipped in a solution of pH is equal to 3 at 25 degrees Celsius. The potential of the cell would be dash volt. Again, a simple question. Okay. So hydrogen electrode is dipped in a solution of pH is equal to 3 at 25 degrees Celsius. The potential of the cell. So E cell is given by E0 cell minus E cell is equal to E0 cell minus 2.303 RT divided by NF log of the concentration. So for here, this is a hydrogen electrode. So it is 1 by H positive. And for hydrogen electrode, N is equal to 1 and E0 cell is equal to 0. On substituting, E cell is equal to 2.303 RT divided by F is 0.059. So that is minus 0.059 multiplied by log of H plus concentration, that is pH is equal to 3. Say H plus concentration is 10 raised to minus 3. So log of 1 by 10 raised to minus 3 becomes 10 raised to 3. 3 multiplied log 10 whole power 3 is 3 multiplied by log 10 to the base power 10. Log 10 base 10 is 1. So it is minus 3 into 0.059. That is approximately equal to minus 0.177 volt. So negative, it is already given in the question. So the answer is 0.177 volt. So numerical type question, simple question, just solving by applying the formula and some concept about hydrogen electrode. N is equal to 1, E0 cell is equal to 0. And so this is okay. We'll solve one more question, 50th question, so that we can wind up. So the value of delta O for tetrachloride rhodium 3 ion is 243 kilojoules per mole. It is 243 kilojoules per mole. Wavelength of light will promote an electron. Wavelength of light in nanometers will promote an electron from the T2G set to EG set is. So we know that E is equal to Hc by lambda, right? E is equal to H. E is equal to Hc by lambda. So delta O, it is given for 243 kilojoules per mole, but it is given to promote an electron. So what is the energy? So this is E is delta O, that is equal to Hc by lambda. This is for 1 mole. For 1 electron, it is delta O is equal to Hc by lambda multiplied by the Avogadro number. So Hc by lambda multiplied by Avogadro number. So we want to find what is lambda. So just we have to just substitute. Say it is 243 kilojoules. 243 into 10 power 3, that is equal to H into C divided by lambda. We know this is 6 into 10 power 23. So on solving this, you will get, please solve. We are running out of time. I'm just skipping the calculation part. To solve, just substituting the values, you'll get lambda is equal to 492 nanometer. And the answer for this question is 492 in nanometers. Okay, 492 nanometers. So I have discussed one full paper JEE mock test, and some technical issues were there. So you can, so in the paper we have got important questions. Organic நிறைய இருந்துச்சு, and this question coordination compound is very important. I have explained எப்படி நம்ம hybridization கண்டுபிடிக்கணும் in an elaborate way. Please pause the video and you can solve that kind of questions. So any doubt you can put in the chat section, or else we can wind up. So thank you for listening. Thank you.